In this program, we are going to create a setpoint management program based on a real-time clock. First, we start with the declaration of the variables inside the program. First, we declare our function block instance DailySchedule, which will handle the time range logic for the night offset. Then we define the RDC time inputs, RDC hour and RDC minute. These values represent the real-time clock coming from the PLC. After that, we declare the night offset parameters. We define the start time at 10 p.m. and the end time at 7 a.m. This means the night offset will be active during this time range. Next, we declare our status variables. Night offset status is a Boolean variable. It will indicate whether we are inside or outside the defined night schedule. Current temp reference is a real value. This will store the final temperature reference sent to the controller. Then we define the base temperature settings. Base temperature is set to 22 degrees. Night offset value is set to 5 degrees. This means during night mode, 5 degrees will be added to the base set point. Now, let's move to the main logic. We call the DailySchedule function block. We pass the RDC hour and minute as inputs. We also pass the start and end time parameters. The output of the function block is connected to night offset status. This means the function block will automatically determine whether the current time is inside the defined schedule. After that, we implement the if condition. If night offset status is true, then we add the night offset value to the base temperature. So the current temp reference becomes 22 plus 5, which equals 27 degrees. If the status is false, then the current temp reference remains equal to the base temperature only, which is 22 degrees. So in summary, during the night schedule, the set point increases to 27 degrees. Outside the schedule, it returns to 22 degrees. This makes the set point management dynamic and fully controlled by the time schedule.